Hello, this is Mrs. Grosh, and the topic for today's lecture is Under the Crust. We can think of the Earth as being round like a ball, but you know that the surface of the Earth is not perfectly smooth. It has lots of shapes on it that we call landforms. And although some of those landforms are created by things that happen outside of the Earth's surface, things like weathering and erosion from the environment, some landforms occur when something pushes up from underneath the crust, something we can't see. To understand why this happens and what's going on, you have to understand about the structure of the Earth and what's going on underneath its surface. So that's what we'll talk about in today's lecture. First, some basic facts about the Earth's structure. First, its size. If you were to travel from the surface of the Earth down to its center, the amount of kilometers that you travel would be about 6,400. Now, that's not exact, and it really depends on where you start. If you're starting from the top of a mountain, you'd go farther than if you're starting from under the ocean. But on average, it's about 6,400 kilometers from the top of the surface down to the center of the Earth. And as you go from the top to the center, the texture and composition changes. Composition, by the way, is what the Earth is made of. One thing you'd notice if you were traveling from the surface of the Earth to its center is that the temperature would change. It would get extremely hot. On average, at the surface of the Earth, which is where we walk around, is maybe about 20 degrees Celsius. Of course, that depends on where you are, but on average, about 20 degrees Celsius. If you were able to dig through all the layers of the Earth and get to the center, by the time you got there, it would be about 6,000 degrees Celsius, which is actually hotter than the surface of the sun. Of course, we can't actually dig down to the center. In fact, the deepest hole ever drilled by humans is in Russia. It's about 12 kilometers deep. It was very difficult to dig it, and it didn't even break through the crust of the Earth. So a lot of what we figure out about what happens underneath the Earth's surface is based on what we call indirect evidence. Indirect evidence is when you use things that you can get information about, observations, measurements, and then you use those things that you can observe to figure out stuff that you can't see, either because it's too far away, or too small, or too large for us to observe it. One way that scientists have come to understand some information about what's going on underneath the Earth's crust is through earthquake waves. Scientists who study earthquakes know that the waves of energy from an earthquake can actually travel through the Earth. But what's interesting is that when they travel to a certain level, they bend. And scientists know that some types of earthquake waves can't go through liquid. So this has told them that there's actually a liquid layer inside the Earth. Another clue that scientists use to understand what Earth is made of are meteorites. Meteors are chunks of material that are floating around in space. They were formed at the same time that the Earth was, and they should have a similar composition to Earth. Most meteorites actually burn up as they enter the Earth's atmosphere, but large ones survive, and scientists can study them. One thing that they've noticed about meteorites is that they're very full of iron. They have a much higher percentage of iron than we have on the surface of the Earth. So that tells scientists that there's probably a lot more iron in the Earth than what we can get in the surface. It must be somewhere else, maybe down below the Earth's crust. Using indirect evidence, scientists have decided that the Earth has 4 distinct layers, and they're distinct either because of what they're made of, or what state of matter they are, or their temperature and how they are able to conduct heat. The names of the 4 layers that you should know about are, starting from the center, the inner core, and around the inner core there's an outer core, Around the outer core is a layer we call the mantle, and you can see it has a few different parts, but for now we're just going to call it the mantle. And then around the outside you have the crust. So those are the four main layers that you need to know about. But as you can see, it's somewhat more complicated than that. For example, the crust. Now you already know a little bit about the crust. You know it's the outside layer of Earth, and you know it's made of two different types of rock. What you might not realize yet is that the rock basalt is mostly found under the oceans, and it's very thin and very dense compared to the other type of rock, which is called granite, and that is found under the continents. It's much thicker and less dense. And of course, because it's thicker, that's why those parts of the Earth's crust stick up, not only for mountains, but also for the part that we walk around on. The basalt is thin, and so that thin layer gets filled up with water on the outside of it. The water isn't part of the crust, it's just covering the crust in the low spots. The crust isn't very thick. It's less than 1% of the total distance from the outside of the Earth to its center. But even though it's not very thick compared to the size of the Earth, remember, humans have never been able to drill down past the crust. We haven't even made a dent. You'd have to go much, much farther than at the distance that humans have been able to drill to get to the next layer down. The second layer of the Earth is called the mantle. It's the thickest layer, and it's made not exactly of rocks, but of minerals. Those minerals are very, very hot. They're not hot enough to really be melted, but they flow. They are hot enough to move around the way that peanut butter or asphalt can move around. And that's really important when you learn about some things that happen to create those tectonic landforms that we started to learn about. Sometimes when people talk about the crust, they use the word lithosphere. The lithosphere is a little bit different because it's the crust, but it's also the top part of the mantle. So if you look at the enlargement in the picture, the crust plus that upper layer of mantle together, they're very solid and brittle, and that's called the lithosphere. So even though they're made of different materials, they behave in a similar way. So that brittle outside layer, which is crust plus part of the mantle, is called the lithosphere. Underneath it is a layer, it's part of the mantle, it's made of minerals that are very hot, and it's very slippery, and that's called the asthenosphere. So it's part of the mantle that's down below the lithosphere. And it's very important for something you'll learn about in just a few minutes. Because the difference between the lithosphere and the asthenosphere makes things happen. Before we talk about what happens and what it creates, let's learn about the last two layers of the Earth. Moving down beyond the mantle, you have the core. Now, the core is divided into an outer core and an inner core. They're actually made of the same material. They're made of iron and nickel, which are metals. They're very dense. And they're so dense that scientists think that when the Earth formed, those very dense, heavy metals just sunk down to the middle because they're so much heavier, and so gravity pulled them down towards the center. There's a difference between the outer core and the inner core. They're both so hot that the iron and nickel, which are metals, can be melted. So the outer core is made of metals that are liquid, but the inner core, even though it's just as hot, if not hotter, is made of metals that are solid. Well, why would they be solid if they're hot enough to be melted? The reason why is because of the pressure of the weight of all the layers up above that inner core pushing down and squeezing it keeps the molecules tightly together. So they actually are solid, even though they are hot enough that they should be melted and liquid the way the outer core is. Now, if you remember, I said that you were going to learn why the difference between the lithosphere, which is very brittle and solid, and the asthenosphere, which is very hot and slippery, why that's important. And I'm going to tell you about that now. I'm sure you've been waiting and very excited about this. Plate tectonics is a theory, and the theory is that the Earth's lithosphere is actually broken. It's broken into big pieces, and those pieces can slide around on the asthenosphere, which is more slippery. And if this theory is true, it explains a lot. It explains a lot of tectonic landforms, such as tectonic mountains and volcanoes, things that we haven't really studied yet, but which we'll learn about now, like rift valleys and mid-ocean ridges. It even explains why earthquakes happen. It's all because when those plates meet at a boundary, they're pushing against each other, or they're pushing away from each other. And as those plates move around, at the boundaries, the crust can change. It can change a lot and force things to happen. You'll learn more about the kind of things that happen and the kind of landforms that are created as you continue this unit in class. But for now, you've finished the lecture called Under the Crust. Thanks for listening. I'll see you in class tomorrow.